Hey guys, video number 3 about limits. Up here, I wrote the answers to the 5 problems that I did not do in the video that are on the 4th page of the notes, the first slide on the 4th page of the notes. It looks a lot like the last one I did in the last video. So if you have trouble, refer to that. If you still have trouble, come talk to me about it. So the next slide starts our adventure into doing these things analytically. And it says, what if you're given a function but not a picture? So you could think about the picture if you wanted to, but you don't have to if you don't know what the pictures look like. It's helpful to know what the pictures look like, but if you don't know, that's fine. What you would do for a problem like this, they give you a limit as x approaches some number, and they give you a function. This is like the limit of this function. So the first thing you want to always do with these is just try and plug this number in. If the function is continuous and there's no holes or anything at that x value, then just plugging this in is going to be the answer to this limit. So if I just plug a 2 in here for x, I say, well, okay, so let me just try and plug a 2 in. So the limit as x approaches 2 of this function. X squared minus x plus 1. It's just going to be, just try plugging a 2 in. 2 squared is 4 minus 2 plus 1, that equals 3. Since that worked, like I didn't end up dividing by 0 or taking the square root of a negative or something, this is the limit. This is the answer. And so that's a pretty easy one. All you got to do is try plugging it in and see if it works. So we can try that again for this one. Well, this limit might be equal to, if I just plug a 1 in for x, that'd be the square root of 10 times 1 is 10, minus 1, the square root of 9, which is 3, and that's good. It's good to go. The answer to this problem, what is the limit as x approaches 1 of root 10x minus 1? That equals 3. And if we looked at a picture and we traced it from the left and the right, as x approached 1, the y would approach 3, just like we saw in the previous videos. This one, again, it's a limit as x approaches a value. I'm just going to try and plug it in. Here I have a fraction, so I'm like, maybe the bottom will be 0. If that happens, that means that you have to do something else. But let's just try it first. So this limit is equal to 2 times 1 is 2 plus 1. And then 3 times 1 is 3 minus 2. That's 3 over 1, which is just 3. So that one worked. Again, this limit was 3. That limit was 3. This limit is 3. I wonder if that one will be 3. That feels like something I would do. Let's try that one. So again, if you have a limit, you're like, there's a fraction, so maybe something bad is going to happen, but maybe not. So just plug a 1 in. 1 squared is 1 minus 1 minus 2. And then x is 1, so I get 1 minus 2. 1 minus 1 is 0. 0 minus 2 is negative 2 over negative 1, which is equal to 2. So that limit didn't equal 3, but that doesn't matter. It equaled 2. That's fine. So the first way you should always try to evaluate these limits analytically is, I would call that evaluation. You just plug in the value you were given and see if you get see if you get a number that works. So they're not always going to be that easy, I promise. But that's always the first thing you should try, because sometimes they are that easy. The next slide, which is on page 5, says they will not always be that easy. And that function is this same function, but instead of x equals 1, we used x equals 2. And the reason we did that, maybe you can see, maybe you're looking ahead, maybe you're like a overachiever. You can see that if I plug a 2 in here for x, I'm going to get a 0 on the bottom of this fraction, and that's not going to be helpful. But just so we see that happens, the first thing you should try is evaluation. So I just plug a 2 in for x, and I see I get 2 squared minus 2 minus 2 over 2 minus 2. This is 4 minus 2 is 0. 0 on top is okay. That's just 0. If it's a fraction, 0 over a number. But here I get 2 minus 2, which is 0 over 0. No good. That doesn't work. So how do I find this limit? Well, it's possible that it doesn't exist. If it was like a number on top and a 0 on the bottom, that would be it doesn't exist. We call a limit like this when it's 0 over 0. That is indeterminate. Okay, it's like not 0, it's not 1, it's not anything it's not any useful value. So what's going to happen? For almost every problem you're going to see, there's going to be a way to manipulate this thing with algebra. That's why we call this method analytical or algebraic, where you'll eventually be able to plug the two. So the first way not the first, but the way you guys learn to manipulate functions in Algebra 1, for example, is to factor things that look like the numerator of this fraction. I would call that a quadratic trinomial. And the way that we factor those is we say x minus 2 times x plus 1 over x minus 2. I factored this x squared minus x minus 2 to be x minus 2 times x plus 1. Just for a laugh, I can check. Negative 2 times 1 gives me the negative 2 I wanted there. And negative 2 times x is negative 2x, and then plus 1x is negative x, so this works. And you can see what this shows me is that the reason that this was 0 over 0 is that there was a factor of x minus 2 on top and a factor of x minus 2 on the bottom. And when x is 2, this factor is 0 and that factor is 0, and that's why I got 0 over 0. But what you know now is you're like, well, if I have a factor of x minus 2 on the top and on the bottom, I can cross them out. So this becomes the limit as x approaches 2 of x plus 1. And now I can try just a straight evaluation. X equals 2. Evaluating at x equals 2, and I get 2 plus 1, which is equal to 3. So you can see you always try evaluating first. If you get something indeterminate like this, 0 over 0, that means you're going to have to do some kind of manipulation algebraically. And then once you do that manipulation and you tend to cross out a factor, something like that, you will end up being able to evaluate. You'll end up being able to just plug the value in for x and see what it is. So this is like a very common problem. You should expect there to be problems like this on your test. But again, there's like a pretty straightforward algorithm, like step-by-step process you would use to solve them, where you should always try and evaluate, just try plugging in the x value you're given first. And if that gives you something indeterminate, it'll often be 0 over 0. Then you have to do some kind of, you gotta kind of mess with this thing until you can plug in a number without getting something indeterminate. So first up, evaluate at x equals negative 3. So I'll plug a negative 3 in here and here. Negative 3 squared is 9 minus 9. And the bottom of negative 3 plus 3, that's 0 over 0, and that is indeterminate. Which means I'm going to have to do some kind of manipulation here. So maybe you saw that, you recognized that that was the limit as x approaches negative 3, that the x squared minus 9 is the difference of squares. X squared minus 3 squared, x plus 3 times x minus 3. Now I can cross off the x plus 3's. This is now the limit as x approaches negative 3 of x minus 3. And now I'm going to try my evaluation again. And I get negative 3 minus 3, which is equal to negative 6. So this limit, our original problem, the answer is negative 6. And we get there by doing some kind of algebra to make it so that I can actually evaluate it at that point. I am going to stop here, and I'll do the next couple problems in the fourth video.